This is section 8.2, proving triangle similarity by AA. And we will start by reading the theorem. It states that if two angles of one triangle are congruent to two angles of another triangle, then we can say that the two triangles are similar. The reason the AA Similarity Theorem works is because it invokes the Third Angle Theorem. Recall the Third Angle Theorem for triangles states that if two angles of one triangle are congruent to two angles of a second triangle, then we can conclude that the third angles are congruent because all triangles have 180 degrees. So now that we know that we have two triangles with three congruent angles, if we recall the definition of similar polygons, they are the same shape but different sizes. And the question is, what constitutes the same shape? Well, the same shape has two requirements. First, same number of angles. Second, angles are congruent. If you satisfy those two criteria, you get the same shape. They may be different sizes, but that's okay, because now we know the sides are proportional, and we can use that to solve problems. So here in our first example, it says determine whether the triangles are similar. If they are similar, write a similarity statement, and we can explain our reasoning. Well, right away, we see that angle D is congruent to angle G. Because all right angles are congruent. But now we have to use some of our math facts, and we can say here we have 90 plus 64 plus angle K is equal to 180 degrees. That gives us 154 plus angle K is equal to 180 degrees. And when we solve for angle K, we get 26 degrees. We now know that we have a second pair of angles that are congruent. So angle K is equal to 26 degrees because 180 degrees in every triangle. And now we can say that angle K is congruent to angle C because they have the same measure. And finally, we can say that triangle CDE is similar to triangle KGH by AA Similarity Theorem. So notice that I started with CDE. C is 26 degrees, D is 90, and then E is the third angle. And I said, well, let's start with the 26-degree angle in the second triangle. That was K. The 90-degree angle was G, and then H was the third angle. So we got the order correct. Remember, order is important when writing similarity statements. So here's example 2, using the AA Similarity Theorem, show that the two triangles are similar. So notice the first triangle is triangle ABE. And then the second triangle is triangle ACD. And what I did was I drew these two triangles out separately, and that is to illustrate that both of these contain angle A. So we know that angle A is congruent to angle A by the reflexive property. And we know that angle ABE is congruent to angle ACD because they have the same measure. So yes, these two triangles are congruent by the AA Similarity Theorem. If we look at problem B, we want to focus on these marks, which tell us that SR is parallel to TU. And when that's the case, we want to use our transversal and congruent angle theorems. And right away, we can see that angle S is congruent to angle U using the alternate interior angles theorem. And then we can say that angle SVR is congruent to angle TVU by vertical angles. And again, once we've shown that two angles are congruent, these two triangles are similar by the AA Similarity Theorem. So now this brings us to an application problem, and it's not enough just to show that two triangles are similar. Now we can use that to aid in solving for problems involving distances and lengths and measures. So here it says a flagpole casts a shadow that is 50 feet long. So here's the shadow. Shadows always lie on the ground, and we know that that shadow is 50 feet. Remember that the shadow is the result of the sun's rays getting past and lighting the ground beyond it. But the pole blocks the sun's rays and casts the shadow. So if we look at this, we should say, well, we have a triangle here. This is a right triangle because whenever we put up flagpoles, they are perpendicular to the ground. And then it says, at the same time, a woman standing nearby who is 5 feet 4 inches tall casts a shadow that is 40 inches long. So we could say that this is another right triangle, the person and their shadow. Again, it's a right angle. And the sun hits the ground at exactly the same way, creating congruent angles here. The sun's rays are parallel. So if the sun's rays are all parallel, the ground acts as the transversal. And what we have here are corresponding angles that are congruent. So whenever we deal with a shadow problem, we're using AA similarity between the two triangles that we draw in place. Now, we have different measurements. I have feet, I have inches, and I have feet in inches. So let's change everything to inches, and we're going to draw this as a simpler picture. So here's our flagpole, and we're going to convert that 50 feet to inches. So 50 feet times 12 inches per foot equals 600 inches. We don't know how many inches high the flagpole is, so we're going to call that x. That is what they're asking us to solve. That is the unknown. We know the person's shadow is 40 inches, but we now need to convert 5 feet 4 inches to just inches. So 5 feet times 12 inches per foot equals, plus the 4 inches gives us 64 inches. And now we can write our proportion. I can take 64 over 40 equal to the x over 600. Remember, proportions have to be written following a pattern. So I took the height of the person and put it over the shadow of the person. Height over shadow. And then I took the height of the flagpole and put it over the shadow of the flagpole. Height over shadow. That is a consistent pattern that we followed when writing the proportion. Proportions must follow patterns. Now we know how to solve these. We cross multiply. So it's 64 times 600 equals 40 times x. So 64 times 600 equals, and we have 38,400 equals 40x. Now we're going to divide both sides by 40. Divided by 40 equals 960 is equal to x. And remember, this is in inches, but that's not what the problem asked for. He asked for the nearest foot, so that means we're rounding it to the nearest whole number when it says nearest foot. If it wanted a decimal, it would say the nearest tenth of a foot or the nearest hundredth of a foot. That's not what it says. It says the nearest foot, so we're rounding it to the nearest whole number. So we're going to divide that 960 by 12, and it tells me 80 feet. That is the height of the flagpole. So here are some problems to practice identifying similar figures. It says, determine whether the triangles are similar. If they are, write a similarity statement and explain your reasoning. Well, we see that we have H is congruent to J. Those are both right angles. And we need to use the fact that there's 180 degrees in a triangle to solve for one of the third angles. So here we see that we have 90 and 48. 90 plus 48 plus angle F have to equal 180 degrees. 90 plus 48 is 138 plus angle F equal to 180 degrees. And when you subtract 138 from both sides, we get that angle F is 42 degrees. And that makes angle F congruent to angle K. So we have an angle pair and a second angle pair. Now we can name the similar triangles. I'm going to start with the 42 degree angle, then the 90 degree angle, then the 48 degree angle. Remember, order matters. So triangle FHG is similar to triangle KJL by AA Similarity. Now for example 4, they're showing us we have 35 degrees on angle S and 35 degrees on angle T. So we can simply say those are congruent. They have the same measure. And once again, we use the fact that there's 180 degrees in a triangle to solve for one of the third angles. So we can say 35 plus 65 plus angle V equals 180 degrees. And when you solve this, you'll get that angle V is equal to 80 degrees. And we say, well, that is not the same as angle Q. So these triangles are not similar. So here we are given that triangles are similar. This is our given. And we're being asked to solve for sides. So AC is unknown. And we have to say, well, MA goes to GE, MA over GE, and that's going to be equal to AC over ET, and that's going to be equal to CM over TG. And from here, we say, well, let's fill in the information we know. MA is 30, GE is unknown, so I'm going to give that a variable. I'll call it X for now. AC is unknown. I have to use a different variable. Let's call that Y. ET is 20. CM is 20. And TG is 16. And we said we can only use one equal sign at a time. So we can say that Y over 20 is equal to 20 over 16. And then we can take these two and set them equal. 30 over X is equal to 20 over 16. And not only are we using one equal sign at a time, we're solving for one variable at a time. And now we can do each cross product. 16y equals 20 times 20 is 400. Y equals, we'll do 400 divided by 16. And that gives us 25. And now this cross product is 20x equals 16 times 30. That gives us 480. And now we'll divide that by 20. And that gives us 24. So remember that X we put in place of GE. So GE is 24. And Y we put in place of AC. So AC is 25. Once again, they've given us a similarity statement. We should begin by writing out our proportions. MN goes over SQ. NP goes over QV. And PM goes over VS. So now we can do the substitution step. MN gets replaced with 10, SQ with 15, NP with X plus 3, and QV with 2X plus 4. This is our proportion. When we cross multiply, we get 10 times 2X plus 4 equals 15 times X plus 3, 20X plus 40. Remember, we're using distributive property here. Equals 15X plus 45. Let's get the X's together on one side and the constants on the other. Subtract 40 from both sides. We get X is 1. And if we plug that into NP, 1 plus 3 is 4. And if we plug that into QV, 2 times 1 plus 4 is 6. So that's the end of this lecture. Go back, watch it again, take your notes, and come to class with questions.